Hello and welcome to another LeetCode video. Today we're going to be doing problem number 280, wiggle sort. And it's going to be similar to a problem I did yesterday, but I'll kind of get into that. But it has like another cool algorithm you can learn that's pretty rare. So you're given a bunch of numbers and you want to sort them in a way that num0 is less than or equal to nums1, which is smaller than or equal to nums2, which is less than or equal to nums3, and so on. And so you want to have it kind of like in a pattern like this, where you have like a small number, a big number, small number, big number, small number, big number, small number, but they are allowed to be equal. So any two numbers next to each other are allowed to be equal. And so for this first example, this 352,164, they're saying a solution is 351,624. And so we can even draw it like that, right? So if you have six numbers, you'd have 1, 2, 3, 4, 5, 6. So you could see that that's the case, right? So you have 3, 5, 1, 6, 2, 4. And you can see that fits this. So let's go to the next one. And in the next one, we're going to have numbers that are the same. And so if they're the same, it's okay to have them next to each other because numbers next to each other are allowed to be equal in this case. So now their solution is, let's do this again. So let's do this like this. Okay, so we have 6, 6, 5, 6, 3, 8. So yeah, you do have some numbers that are equal, like these two, which is fine because that is fine for the constraints. So let's think about how we would do this. So one thing that I did mention yesterday is pretty straightforward. So if we do have this like 352,164, one thing we can actually do is we can sort the numbers. So we can just go 1, 2, 3, 4, 5, 6. We can sort the numbers and we could have a pointer to each side. And then we just know like, okay, are we on the small or the big index, right? We can just like we can just alternate the indices and then we can just put in like a small and then a big and then a small and then a big and then a small and big until we run out of numbers. So that would look something like 1, 6, then we would move these pointers over here. Then we would take the 2 and the 4, and then we'd have one last number. We'd take the 2 and then the 5, and then we have the 3 and then the 4 left, which is totally fine. Like this is one way to do it, but the problem with this is n log n. So we're actually going to introduce a faster way of doing this. And so it's going to be pretty straightforward, but let's go through this example. So we're going to write this 352,164, and we are going to clear it up. And so basically what we're going to do here, and it is a little intuitive once you understand it, and it's even more intuitive when numbers are unique. But it still works obviously when numbers are not unique. So if numbers are unique, for every two numbers, one has to be greater and one has to be smaller, right? No matter which order I have all these, for any two numbers, one has to be greater and one has to be smaller. And so what we're actually going to do is we're going to go through these and we're just going to go index by index and ask ourselves like, okay, what index are we at? And do we want the smaller number or the bigger number? And if we have it the other way around, then we're just going to flip them until we get to the very end. So we're going to start at this index and we're going to say, okay, so we want our first number to be small. So we're going to compare these two numbers and we're going to say, okay, is this first number bigger than the second number? No, it's not. So that's totally fine. So we're going to leave that as is. Okay, now we're going to go to the second number. And we are going to say, okay, well, for this, do we want this number to be big or small? Well, we want it to be big, right? Because it's an even number index. So we want small, big, small, big, small, big, and so on. So we want this to be big. We know that like we already compared this part's fine. Now let's compare these two. If we want this number to be big and it's smaller, we can flip them. And if it's not, then it's fine. So we can check. It's actually already fine. Okay. Now we are going to go over here. And do we want a small or a big number here? So we actually want a small number. Okay, we're going to compare it to this number 1. And we can see, oh, okay, well here, we actually want the 1 to be before the 2 because we want the small number, but we have the big number. So we're actually just going to flip it. And so we're going to take this and delete it real quick. And now we have 1, 2, okay? And now we're at this number, and we want it to be the big number. And like I said, you don't have to check the previous ones because if this is the small number, then this has to be the big number. So that makes sense. So what we can do now is we can compare this to to the next number, and we want this 2 to be the, let's see, so this is small, big, we want it to be the big number. Okay, so in that case, it's clearly the small number, so we're going to flip again. So we're going to delete this number, and we're actually going to swap them. So now we're going to have the 6 here and the 2 here. Okay, so now we are at this number. And do we want this number to be the small or the big number? Well, remember, it's small, big, small. So we want it to be the small number. We compare here, and that's correct. And so now that you can see that our final outcome is, right, so small, big, small, big, small, big. But now we actually did this in place in a one pass. So this is actually going to be n complexity, where we were just greedy and we just say, instead of sorting or anything, we can just keep flipping numbers so we get to the very end, and we're guaranteed to have a solution. So let's actually do this thing again for this second example, and then we'll be done. So we have this 6, and I'll show you that it also works for numbers that are the same. Except you're just going to not have to do as many flips, because a lot of times you'll just have numbers that are the same, so it works for everything. Okay, so we're going to start at this 6 right here, and we're going to compare it to this 6 over here. Well, if they're the same, then it doesn't really matter, right? We don't need to flip it, so we move on, because numbers next to each other are allowed to be the same. So now we're at this 6. We want this 6 to be the big 6, so we want this to be the big number, and it is. Okay, now we want this 5 to be the small number, and that is the case. Now we want this 6 to be the big number, and that is the case. And then we want this 3 to be the small number, and that is the case. And then we want the 8 to be the big number. So that's actually, yeah. So in this case, it's already sorted, but it would work if it wasn't. And let's actually do that. So let's actually make it in a way where we have to do some stuff. So let's just say we have something like on a rearrange order. So let's just say we have like 8, 6, 6, 3, 5, and then we have one more 6. Okay, there we go. So now let's do it this way. There we go. Now there's actually going to be some work to be done. Okay, so we want this 8 to be small. It's not, so we're going to need to flip these two numbers. Okay, pretty straightforward. So we're going to flip them. All right, so it's going to be this right here. Right, so it's going to be 6, 8. Now that's correct. Now we need this 8 to be big. It is. Now we need the 6 to be small. It is not, so we're going to need to flip the 6 and the 3. Okay, flipping. So then we have 3, 6. So now we want the 6 to be big, and it is. And now we want the 5 to be small, and we have a solution again, right? So 6, 8, 3, 6, 5, 6 would be a solution, and that's, yeah, so that would work as well, because if you look, we have small, big, small, big, small, big. So hopefully that makes sense, that you can just take this greedy solution where you flip numbers in place instead of doing the sort, and that should be the faster solution. So let's actually code that up. So we're just going to say for I in range of length nums -1, because once we get to the last number, we're going to compare the number to the number after it. So we don't want to compare the last number because there's nothing after it. So we're going to say if I mod 2. So if this is true, actually I'll just write it cleaner just to make it a little bit easier. So if I mod 2 equals 0, so we'll just write it like this. So this means we have an even index. So if we have an even index, we want the number that we currently have to be small, right? It's small, big, small, big, small, big. So we're just going to compare the number to the number after it. So nums I is greater than nums I plus 1. Then we just swap them. So that's going to be nums I plus 1. And then we can swap them in Python with a one-liner. Okay. Now we have the else case. And so the else case is if we're at an odd index. And so at the odd index, we want the number to be bigger. So let's actually copy this code. It's pretty similar. So if we want it to be bigger, we need to swap if it's smaller. And then the rest of it should be the same. And that should be it. See what happens. Thank you. Okay, so as you can see, this is like a more efficient solution than the sorting, because for the time here, this is going to be big O of n time, and space, it's going to be big O of 1 time. And so that's the final algorithm I wanted to show you guys with how to do this like alternating sequence thing. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next video. Thanks for watching.